Yes, hello my dear students, welcome back. Today in this video I just want to explain you the variation of molar conductivity of weak electrolyte on dilution. Okay, first thing, in the previous video I was successfully explained the molar conductivity, the variation of molar conductivity of strong electrolyte on dilution. We have explained it successfully, and then this is the next part of discussion, that is a variation of molar conductivity of weak electrolyte on dilution. Okay, first let's understand that how weak electrolytes behave. So if I take here weak electrolyte like acetic acid, it dissociate partially. Partial dissociation takes place. Partial dissociation. Okay, this is a part. Now, as the partial dissociation is taking place here, and because of that reason, the number of ions in volume V is less. So therefore, let me write less number of ions in volume V. There is certain volume is there which contains around 1 mole of solute or electrolyte. Now, as I am mentioning that the less number of ions are there in a certain volume V, it means that interionic distance is more. Interionic distance is more. So hope you understood this, because all the ions are separated with a large gap, because only few number of ions are there. Now because of that reason, interionic distance is more, the attraction between the ions is less, hence here the more molar conductivity is there. Okay, so as interionic distance is more, the moment of ions is more, because here the ions are free to move in any direction, or they can move in the direction of electrode. Now on the dilution, something happens here. On dilution, this is the center of discussion for us. Now on dilution, something very interesting happens here. Okay, on dilution the volume is increasing. It is increasing, volume increasing, because you are adding more amount of solvent there. Okay, this is first point. Second point, as the electrolyte we are taken, that is a weak electrolyte, hence the extent of dissociation is increases on dilution. On dilution, extent of dissociation increases here. Okay, as the extent of dissociation is increasing, means number of ions per unit volume is also increasing. Number of ions per unit volume is increasing. It is increased. Okay, both the factors are there in a molar conductivity. In the formula you can say that lambda m is equal to K conductivity multiplied by the total volume. Now K is also increasing here, because as the number of ions per unit volume it is increasing, the K is increasing. As you are diluting it, the volume is also increasing. Both the factors are increasing, in that whatever the increase in the conductivity is, then it is very small. Okay, but increase in the volume is that is rapid. Therefore we can say that there is increase in molar conductivity, and that too sharp increases there. Sharp. Why it is sharp? Because as soon as you add the water or the solvent, the number of ions are also increasing. Extent of dissociation is increasing, and along with that the volume is increasing. Both the factors, the conductivity and volume, both are increasing. Therefore increase in the molar conductivity is very sharp. Hope you understood this. This is all about the variation of molar conductivity for weak electrolytes. Thank you for watching it, students.